Welcome back. In the previous video, we established a few rules around logarithms. In this video, we're going to try and solve some logarithm expressions. Now, to do these particular problems here, we're going to rely on the rule that we established at the end of the last video. So substituting 1 into 2 gives x equals log base a of a to the power of x, or we can say that log base a of a to the power of x is simply equal to x. So we find that a log of base a cancels out a base of a. So this rule right here. So the log a cancels the a and we're simply left with the x's. So jumping into a few problems, look at log base 3 of 243. So log of 3 of 243. To apply this rule that we used or that we've observed up here, notice that we have to have the log base, so this 3 here, we have to have this number that's been applied through the logarithm as a power of 3. So to solve that sort of problem, we first have to factorize 243. So 243, we ask ourselves, we want to write 243 as a power of 3. And we ask ourselves, well, what, or 3 to the power of what equals 243? And we instantly find that it's 5 using our calculators. So log base 3 of 243 can be rewritten as log 3 of 3 to the 5. And then using the rule that we established earlier, we find that the log 3 and the 3 here, they cancel. So we're simply left with 5. So 5 is our answer. Going over to B, log base 5 of 0.04. So notice what's interesting about this problem is that 0.04 is less than 1. So we're expecting an answer that's going to be below 0. So factorizing this 0.04 as a power of 5, 0.04 as a power of 5, we ask ourselves, well, 5 to the power of what equals 0.04? And we're not quite sure. So let's try and simplify it a little more. And we'll say that 1 over 25 is equal to 5 to the x. So if I take the inverse of this, 0.04, we get 1 over 25. So going a little bit further, we get 5 squared. And then finally 5 to the negative 2. So rewriting our logarithm, we can write it as log 5, log base 5. It's the same as saying 5 to the negative 2. And working with this, we see that the log base 5 and the 5 here, they cancel. So all we're left with is negative 2. So we can write log base 5 of 0.04 is negative 2. And this one was 5. Now we move on to a more complicated example. Log base 2 of the 5th root of 4. Now again, there's quite a lot going on here. Firstly, we've got this radical which isn't particularly helpful, although it might look neater. So the first thing I'm going to do is get rid of the radical. So we'll go log base 2 of 4 to the power of 1 over 5. And then we have to rewrite this as a power of 2. So the square root of 4 is 2, so we can say 2 squared is equal to 4, so we can write log base 2 of 2 squared times the 1 over 5, because we can't forget about that. And then log 2 of 2 to the power of 2 fifths. And using our rule that we established earlier, these logs or log base 2 and the 2 cancel, so we're simply left with 2 over 5. So the answer to this question is simply 2 over 5. Now moving on to some more difficult questions, we have to take into consideration a different case. So if no base is shown, then base 10 is assumed, giving the special case log 10x simply equal to x. So if we dive into this question, we've got log 10,000. So we can rewrite this as log 10 to the 4. And remember that the base of 10 is assumed in this case. And because it's assumed, the log base 10 and the 10, they cancel. So we're simply left with 4. Now over in E, we've got log and the cube root of 100. So we can rewrite this as log 10 squared, all to the cube root, and then we can go log 10 to the power of 2/3, like so. And then because the base 10 is assumed or implied, these bases and the logarithm, they cancel. So we're simply left with 2/3. So we'll leave it there for this video, and in the next video we'll tackle some trickier problems.